Have you ever wondered, what exactly is this thing we call light? The same light that lets your eyes see the world, turns on your mobile screen, races through internet fiber optic cables, and carries messages from stars that are thousands of years away. In this documentary, we will discover what light really is, how fast it travels, whether it is a wave or a particle, and how it controls everything from our daily life to the entire universe. The light we see every day is called visible light in science. It is the part of the electromagnetic spectrum that the human eye can detect. The electromagnetic spectrum is like a big family. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays all belong to it. But our eyes can only see a small middle portion as different colors. The human eye usually detects wavelengths from about 400 nanometers to around 700 to 780 nanometers. At the shorter end we see violet blue, and at the longer end we see red. One of the most famous facts about light is its speed. In a vacuum, or empty space, light travels at about 299,792,458 meters per second, which people commonly round to 300,000 kilometers per second. This means that if you could ride on a beam of light for just 1 second, you could travel around the Earth more than 7 times. According to Einstein's theory, this is the ultimate speed limit of the universe. No information or matter can travel faster than light. At these speeds, sunlight takes about 8 minutes and 20 seconds to travel from the sun to the Earth, which means the sunlight you see right now actually left the sun a few minutes ago. Experiments have shown something very strange and beautiful. Light behaves both like a wave and like a particle. When we look at light as a wave, we can understand reflection, refraction, diffraction, and interference. Just like water waves collide and create patterns, light waves also form bright and dark patterns. But in experiments like the photoelectric effect, light transfers energy in tiny packets called photons, which behave like particles. And quantum physics confirms that light is not just a simple wave, but has a particle nature too. In normal conditions, light appears to travel in straight lines. A simple proof is when you turn on a torch. The beam goes straight to the wall and shadows form with clear edges. The same idea helps astronomers measure the positions and distances of stars and galaxies. Reflection happens when light hits a smooth surface and bounces back, like a mirror, calm water, or a glass building. According to the law of reflection, the angle at which light hits the surface is equal to the angle at which it reflects, which is why your face appears properly ordered and clear in a mirror. Rear-view mirrors in cars, makeup mirrors, periscopes, and many telescopes all rely on this principle of reflection. Refraction occurs when light passes from one medium into another, like from air into glass or water, and its path bends. A classic example is when you put a pencil into a glass of water. At the surface, the pencil looks bent or broken, but in reality the pencil is not broken. The path of light has changed. This bending of light is exactly what lenses use. Glasses, camera lenses, microscopes, and telescopes all use different lens shapes to bend light and form clear images. When white light passes through a prism or raindrops, each wavelength bends at a slightly different angle, a process called dispersion. Because of this, one white beam splits into red, orange, yellow, green, blue, indigo, and violet. These are the colors of the rainbow, and a natural rainbow in the sky is formed by the same refraction and dispersion of sunlight in water droplets. Now, how does all this theory affect our daily life? Inside fiber optic cables, pulses of light bounce again and again due to total internal reflection, carrying data over huge distances. This is the backbone of modern high-speed internet. Lasers, which are very focused beams of light, are used in surgery, barcode scanners, printers, cutting machines, DVDs, and many communication systems. Solar panels convert the energy of photons directly into electricity, getting power straight from light, which has become a major source of clean energy. Medical imaging, TV remote controls using infrared night vision devices that amplify low light or infrared, and UV sanitization systems. All of these depend on controlling different types of light waves. Scientists do not see light as just brightness. They see it as a carrier of information. When we observe light from distant galaxies, their color, brightness, and spectrum tell us how far they are, how fast they are moving, and what their temperature and composition might be. Space telescopes like Hubble capture visible and infrared light and show us a universe billions of light years away. where the light reaching us today has been traveling for millions or even billions of years. In other words, we are actually looking into the past. If you pause for just a second and think, every moment your eyes, your phone, your Wi-Fi, your TV, your glasses, everything depends on light. But most of the time we do not really know what it is. Light is not only brightness, it is information, energy, and the fastest messenger of the universe. So next time you watch a sunrise, turn on your mobile flash, or look at your face in a mirror. Remember, you are not just seeing a reflection. You are witnessing a small miracle of pure physics.